Let's start section 1.6. More equations and applications. So far, we've solved linear equations and quadratic equations and rational equations. Remind me, how can we recognize a linear equation?
In order.
What's that?
In order.
The order of the variable is? Yeah, x to the first power. If you had like ax plus b is equal to c, the exponent is 1, the linear equation, probably the easiest that we'll have to solve. How many solutions can we have to the linear equation? You can have 1 or infinite, all real numbers, or 0. Okay. But then we have what type of equations? What's this called? Quadratic equation. We can have how many solutions? Yeah, so 2 real or 2 non-real complex, or 1 solution if you have a repeated solution. When the discriminant is what? Do we have 1 solution? All right, quadratic formula we solve for x. Negative b plus or minus square root of b squared minus 4ac all over 2a. What's the discriminant? Inside the radical. What creates the 2 solutions is this plus or minus, right? If I add 1 or subtract 1, I get a different number. So when would I get only 1 solution? What number, if you add or subtract it, doesn't change? 0. So discriminant 0, that's when you get 1 solution. All right. The last type of question was rational equations. What does rational mean in math? What's that? A rational number, rational equation, you should think fractions. Okay, so that was type 2. We did this in lecture 1.1, so I'm not going to cover this again. I'm just going to say refer to those notes for 1.1. And I'm not going to ask you to do these problems on homework either. Refer to 1.1 for those practice problems. But the key to these problems was what? Eliminate fractions. You could get the same denominator, but you multiply by the LCD. And when you do that, you may get something called an extraneous solution as a solution that actually isn't a solution. So you must check your answer. Or this one, you'd multiply by v plus 1 times v plus 4 on both sides. Okay, but let's get to the new types of problems. Other nonlinear equations. And we're going to first type 1 solve by factoring. Is this a quadratic equation? No, because the degree is higher than 2. In fact, it's degree 3, so we'd call it cubic. You don't need to know that. But we can still use the 0 factor principle. That means if you make one side 0 and factor the other, you can set each factor equals 0. How might you factor this? If I have 4 terms, what do you try? Grouping. All right. What's the greatest common factor of the first pair? X is a common factor. X squared is the greatest common factor. If I factor out an x squared, I think about what's x cubed divided by x squared? X, very good. And then what's negative 4x squared divided by x squared? Negative 4. What's the greatest common factor of negative 2x and positive 8? Negative 2. If the leading term is negative, take out the negative. And negative 2x divided by negative 2 is x. 8 divided by negative 2 is negative 4. If I have 4 terms, does grouping always work? Guaranteed? No. How do you know if it works? The x minus 4 binomial is the same for each. Then we can factor out that common factor. X minus 4 and what is left over? x squared minus 2 equals 0. Very good. Sometimes you can factor that further. Can you factor x squared minus 2 further? Not with integers. Now we can use the zero factor principle. That says that if two things multiply to make 0, one of them is 0 or the other is 0. So our first solution would be what? 4. And from the quadratic equation side, how do you solve this? Or what's the fastest way to solve it? The square root property. Add 2 to both sides and square root both sides. And what's the mistake I made? Very good. Plus or minus. So our answers, we got how many? Negative root 2, positive root 2, and positive 4. Cubics have 3, possibly with repeated solutions. Yes. Yeah, I'll accept it. I just wrote it out because sometimes people don't realize those are two solutions. Does Alex's system let you plug in plus or minus? Okay. Yeah, I'm perfectly fine with you circling the previous line, the 3 solutions. All right, let's go on to type 4 problems. Because linear absolute values will be on the easier side. I want to make sure we get to harder problems first. Okay, radical equations. Does it have a square root in it? The goal is to get rid of square roots. Square roots make things complicated. The way you get rid of square roots is you isolate it and then you square both sides. Now, what happens if you don't isolate it and you square both sides right away? And sometimes we just need to make mistakes to know not to do it. All right, I'm going to make a very common mistake. And you can tell me what I did wrong. What did I do wrong? Okay, I squared this thing, right? And I squared this thing. You cannot distribute the square. If you have a square of a binomial, then you have to FOIL, right? So if I wanted to actually square that, I would have to write square root of t plus 8 minus 2t multiplied by itself, right? So I'd have to FOIL. Does this make sense? Okay. Be very careful. You cannot distribute squares. And it's going to be tempting, and someone's going to do it on a test. But you want to make the mistake, make that mental note. Make sure you don't do that. Okay, so I said, what do we actually need to do to get rid of the square root? I need to get the square root by itself. So I add 2t to both sides and then square. Thank you. Please put both sides in parentheses and square. Otherwise, this is the same mistake again. What mistake did I do? I distribute the square, but in fact, I should do what? FOIL. So if I FOIL, are you guys okay foiling that in your head? You definitely want to get to the point where you can do that without making a mistake. That's the key part. Or just write it out. First times first, what's 2t times 2t? 4t squared. Outer terms, 2t times 1. Inner terms, 1 times 2t. And last terms, 1 times 1. All right. I have t plus 8 is equal to 4t squared plus 4t plus 1. And the key here is this step, when you square both sides, may create extraneous solutions. So this means now we must check. We cannot believe the answers we get. We must check at the end. What type of equation am I left with now after I squared both sides? Quadratic, and your pros is quadratics, right? All right, let's subtract t from both sides. Let's subtract 8 from both sides, and we get one side 0, 4t squared plus 3t minus 7. Please be factorable. Are you guys comfortable with guess and check? So what are our options for 4t squared? Maybe 2t and 2t, or 4t and 1t? Those are the options. What are the factors of -7? -1, 7, 1 and -7. So we just need to try every combination of each of those, or you can do AC method if you're uncomfortable with this guess and check. All right, what do you want to try? 4t and t? 2t and 2t. 4t and t. I want to get a 7 and a -4. If this is my guess, my check would be 7t minus 4t adds to make 3t like we wanted. Okay. So I've factored this. Now what's the next step? Okay, set each equal to 0. 4t plus 7 equals 0, or t minus 1 is equal to 0. So t is equal to 1, or what? We do that in our heads. Subtract 7 from both sides, divide by 4. -7/4. And I feel great. What's wrong with circling the solution? We must check. I can't believe these. Let's try -7/4. If I check that, what do I get? The square root of -7/4 plus 8. Let's get a common denominator. So what's 8 times 4? 32/4 minus 2 times -7/4. Okay, 32 minus 7 is 25. So I got square root of 25/4 plus is equal to 1. What's the square root of 25/4? Square root of 25 is 5. Square root of 4 is 2. 5 halves plus 7 halves is what? 12 halves. 6 equals 1. No, which means this is, in fact, not a solution. It's an extraneous solution. We cross it out. All right. Does t equal 1 have to work? It doesn't have to, right? For some reason, students get really upset when they both don't work. All that work for nothing. But it's not for nothing. Then your answer is no solution, right? So if we plug in 1, what do we get? Square root of 1 plus 8 minus 2 times 1 is equal to 1. So square root of 9, 3 minus 2 is 1. Yes, therefore t equals 1 is our one and only solution. Any questions about that? All right, what's this monster problem on the right? I have 2 radicals. And the key here is I can only get rid of one at a time. Okay, squaring it does not get rid of both. So how do I get, or which one do you want to get rid of? Square root of x plus 6 or square root of x plus 2? Sure, it doesn't matter, but how do I get rid of it? I must isolate it. So I'm going to subtract the other one from both sides, and I get rid of it by squaring both sides. Okay, so if I square both sides, I may be creating extraneous solutions, but what's the square root of x plus 6 squared? Do I need an absolute value or not? The square root means positive root, right? Positive number squared is positive. So we don't actually need an absolute value. When do we use absolute value? The square root of a square, right? The opposite order. This just cancels out to make x plus 6 on the left-hand side. And we have to be very careful about the right-hand side. Right? What if we have two terms? This addition means we need to FOIL out a binomial. If we FOIL this, what do we get? First times first. What's negative square root 2 times negative square root 2? It's positive, yeah. Positive x plus 2. You know what? I'm going to write it. It's our first time doing one of these. So I'm going to write out every explicit step. The outer terms would be negative 2 square root of x plus 2. The inner terms would be negative 2 square root of x plus 2. And the last terms would be 2 times 2. Okay, a negative times a negative is positive. Square root 2 times square root 2, no, square root of x plus 2 times square root of x plus 2 is x plus 2. All right, we combine these like terms. If I have negative 2 apples and take away 2 apples, I have negative 4 apples, yeah. Whatever that means. Plus 4. Wow, okay, so we FOILed. And what was the result of squaring both sides? I eliminated one radical, but I still have the other on the other side. So now how do I get rid of that radical? Isolate it and square both sides. So what's the first step to isolate it? Let's subtract x from both sides. And let's subtract 6 from both sides. So that would give me, on the left-hand side, 0 is equal to what? Negative 4 square root of x plus 2. So the 2 and 4 canceled with this negative 6, right? 2 plus 4 is 6, minus 6 is 0. All right, so what's the next step? Yeah, let's divide by negative 4. What's 0 divided by negative 4? Yeah, 0 divided by anything is 0. And now that we've isolated the radical, we square both sides. And we get x plus 2 is equal to 0. So our answer is, wow, that was a lot of work. I feel like I should be done, but I'm not done. Have to check, okay. Because I squared both sides, I may have created an extraneous solution. So how do we check? Oh, what a pain. All right, square root of what? Negative 2 plus 6 plus square root of negative 2 plus 2. This one's not so bad. So square root of 4 plus square root of 0 Is it true? 2 plus 0 is 2? Yes, x equals -2 is our one and only solution. All right, so common mistakes. You make sure to FOIL, not distribute the squares, and you need to make sure to check solutions at the end. Any questions about this? All right, the next type would be if I have a fractional exponent. We need to be careful when n is even. So if the numerator of your fraction is even, then it turns out it's going to be a lot like when you had x squared and you took the 1/2 power. What does 1/2 power mean? Square root, right? Square root of x squared. The answer is what? Absolute value x, right? Because you square, make it positive, take the positive root, it's always positive. In the same manner, this is going to be absolute value b. So let's talk about why this is true. A quick example. What's -2 to the 4th power? Yeah, -2 times -2 is a +4 times -2. -8 times -2 is +16. Okay, and the 4th root of 16, it's the positive root, so it's +2. So I put in a -2, I got a +2 out, which means I took the absolute value. So that's why we have to do this intermediate step. Okay, any questions about that? Okay, what if that n is odd? If it's odd, then it turns out you just get b. It's nice. So a quick example. What if I have -2 cubed to the 1/3 power? What's -2 times -2? +4. +4 times -2? -8. And the cube root of -8 is -2. Okay, so I plugged in a -2 and it spit out a -2. Therefore, you just keep the whatever's on the inside. B, you don't need the absolute value. All right, any questions about that? Let us try this first example. I want to get x by itself. Okay, I can write this as x to the 1/3 power to 4th power. Are you comfortable with that? Which rule of exponents am I using? A power to power, you multiply them, right? And 4 times 1/3 is 4/3. So are you okay with me splitting it up in this manner? How do I get rid of a 4th power? I take the 4th root. Whatever you do to one side, you have to do to the other side. Okay, is the answer absolute value or no absolute value? I need the absolute value because it's even, right? So that would give me what? Absolute value of whatever's on the inside, x to the 1/3, is equal to, anyone know the 4th root of 81? Three? Or just plug in your calculator. It is in fact 3. 3 times 3 is 9. times 3 is 27, times 3 is 81. Or you could do 3 times 3 times 3 times 3. 9 times 9 is 81. Okay. So I plug something in the absolute value. And just like with the quadratics, we just know the other side must be plus or minus. Absolute value of 3 is 3. Absolute value of negative 3 is 3. So that's why we plug in the plus or minus. So I really have two equations here. X to 1/3 is equal to 3, or x to 1/3 is equal to negative 3. How do I get x by itself? What's the opposite of a cube root? Opposite of a cube root? You cube both sides. And we get x is equal to 3 times 3 is 9. 9 times 3 is 27. You cube both sides. Negative 3 times negative 3, positive 9. 9 times negative 3 is negative 27. We got two solutions. Any questions about this? Yes. Yes. Is there a way to check it? Yeah. 27. Let me do this off to the side. 27 to the 4/3 power. Plug it into your calculator. Or we have two options. You can take 27, raise it to the 4th power. Can you plug that in your calculator? What do you get? 27 to the 4th? It's really a big number, right? All right, I'm going to erase you. What's 27 to the 4th? Huge number. And now I take the cube root of that, right? Turns out it's easier to take the cube root first because I'll deal with smaller numbers. So I would prefer to deal with the cube root first. What's the cube root of 27? It's just 3, right? Then I get 3 to the 4th is 81. And that's what we wanted. Likewise, we could plug in negative 27. All right, this one, I'll write more steps. So I want to check, is this 81? In my check, I'm going to cube root first. So to show that I'm going to cube root first, I'm going to do 1/3 power and then 4th power. So cube root of negative 27 is negative 3 to 4th power. If you raise it to even power, you get 81 is equal to 81, and it checks out. All right, likewise, you could just write 27 raised to the power of 4 divided by 3. And your calculator can check right away. 81. Any questions about this? Do you want to see a shortcut? Yes, no? Okay. X to the 4/3 power is equal to 81. You could raise both sides to what power right away to get rid of everything? 3/4. Okay, but you have to be very careful. If the numerator is even, it's going to create an absolute value. Absolute value x is equal to 27. I'm just going to trust you can plug that in your calculator. 81 to the 3/4. And then to get rid of the absolute value, you get plus or minus 27 on the other side. So the shortcut is you raise to the reciprocal of the fraction, right? But the problem is remembering if the top number is even, you need the absolute value. All right, any questions about that? Okay, so I'm going to solve the next one the long way first. That is x to the 1/2 power cubed is equal to 27. And I'm going to raise both sides to the 1/3 power first. Now, because this is an odd number, my answer is what? No absolute value. X to 1/2 comes out without the absolute value. The cube root of 27 is 3. And how do I get x by itself? What happened? X to 1/2 is equal to 3. We're going to square both sides. X is equal to 9. And we should check. Check. 9 raised to the 3/2 power is 27. And your calculator will say, yes, it's great. Any questions?
To be clear, doing fractional when you're trying to like simplify them, I think that's what you're trying to do, right?
You're trying to isolate x.
Yeah.
You're trying to get x by itself.
So you have to make the x and the all whatever's in there a sort of.
You have to raise the power where it will make the exponent 1 through multiplication.
That's why you made it like 1/2 to the power, which is in turn is to the second power. Hold on, am I reading that right? The power or 1 bit? I can't see it correctly.
This is 1/3, yeah. To cancel to make a 1. Right? 3 times 1/3 is 1. And I just didn't write the 1. Because anything to the first power is that anything.
Okay.
Yeah. Because we're multiplying, I'm trying to undo that. All right, let's do the shortcut method. How do I get x by itself in one step? Yeah, raise both sides to the reciprocal power, which would be what? 2/3. And then you just have to be very careful. If the top number is odd, no absolute value is required. X is equal to 27 to 2/3 power. It turns out is just 9. And we're done. All right, any questions about that? Okay, the next type of problem is one that's called quadratic in form. This is when the exponent of one variable is twice the other. So while it's not technically a quadratic, we can treat it like a quadratic by doing a substitution. For instance, this problem, I could move these terms over, subtract x squared from both sides. No, x to negative second from both sides. And I could subtract 1 from both sides to get 0 is equal to 20x to negative fourth minus x to negative second minus 1. Okay, what gives it away that this is quadratic in form? -4 is twice -2. So we can do a substitution. Let u be the smaller of the two. The one that is half the other. X to the -2 power. 0 is equal to 20 times something squared minus something to the first power minus 1. This is what quadratics look like But usually this is x, right? 20x squared minus x minus 1. But now we're just going to plug u in. Because this is x to the negative second power. Are you guys comfortable with this step? Why is this true? I multiply exponents. Negative 2 times 2 is negative 4, right? Okay, if I do this substitution, I would write 20 u squared minus what? Minus u minus 1. So this trick works whenever the exponent of 1 is twice the other. You know what? I'm just going to compute u squared. If you square both sides, you get x to the negative second squared. U squared is equal to x to the negative fourth. So I just replace the x to the negative fourth with a u squared. Okay, now that I have a u squared and a u, hopefully this looks like a quadratic to you. And we can solve by factoring, completing the square, or quadratic formula. What do you prefer? Well, just do whichever one you want. I'm hoping this is factorable. 5u and 4u minus 1 plus 1. And I'm just doing guess and check. 4u, wow, the 4 and the u look really similar, huh? 4u and 5u times negative 1 is negative 5u. Do those add to make what we want? They add to make negative u. Very good. Once I've factored it, what do I do? Yeah, set each factor equals 0. 0 is equal to 5u plus 1. Or 0 is equal to 4u minus 1. So our answers would be u is equal to negative 1/5 or u is equal to 1/4. Great, I found u. But what's the question asking for? It says to solve this equation, it implies solve for x, but we solve for u, so this is not my answer. How do I find my answer? You're on the right track. We do what's called back substitute. U is equal to x to the negative second. So we plug back in. X to the negative 2 is equal to negative 1/5. And x to the negative second is equal to 1/4. How do you want to get x by itself? How do you want to solve this? You can raise both sides to the power of. So what would multiply to get rid of a negative 2? 2 times negative 2, no, that's negative 4. What times negative 2 gives me 1? I want exponent of 1. Negative 1/2. It's the reciprocal, right? Reciprocal of negative 2 is negative 1/2. You flip it. Okay, I'm just going to write this a little bit differently, just so you see what's happening here. I'm going to write it as 1 over x squared. Okay, so in this case, I could multiply both sides by x squared, or I guess cross multiply. Are you comfortable with that? And then I can square root both sides. X is equal to plus or minus I root 5. X is equal to plus or minus 2. We got how many solutions? 4 solutions. Too complex two real numbers. Okay. I need to get to the absolute value problem. So I'm going to just start this problem out. Y to 2/3. If I distribute, minus 9y to 1/3. And I'm going to add 8 to both sides. All right, notice that this is twice this exponent. So I could really write this as y to the 1/3 squared minus 9 y to the 1/3. The first power plus 8 is equal to 0. And we could say, let u be y to 1/3. And we could write u squared minus 9u plus 8 is equal to 0. And I'll finish that on the notes, but I'm going to come back to that later. So the key is that 2/3 is twice 1/3. That's when this is going to work. Okay, now I'm going to get to the absolute value equations. Absolute value of 7 has two solutions. Absolute value of 7 is 7. Absolute value negative 7 is 7, right? If the absolute value equals 0, it has one solution. And absolute value can never be negative. So if it's equal to negative, there is no solution. Okay, so this first one, will it have two solutions, one solution, or no solutions? Absolute value equals a positive number. Two solutions, either x plus 5 is equal to 2, or x plus 5 is equal to negative 2. In either case, you take the absolute value and it becomes 2. Then we subtract 5 from both sides. X is equal to negative 3 or x is equal to negative 7. We do not have to check. If the logic follows, then these are right. But you can check. The next one, the absolute value of 2x minus 3 is equal to 0. Which means what? We have one solution because 0 has no sign. It's neither positive nor negative. So we say that 2x minus 3 is equal to 0, or add 3 to both sides, divide by 2, x is equal to 3/2 is our one solution. Absolute value of 2x minus 1 is equal to negative 3. Does that make sense why it's no solution? No solution. If you take an absolute value, it has to be positive. So how could it be negative 3? Cannot be negative. Okay. What happens often is people just set equal to a positive or negative number without thinking. You have to think, does it make sense before you do that? Because what if I did that to this problem? 2x minus 1 equals negative 3, or 2x minus 1 is equal to positive 3. Then it would tell me my answer is negative 1, or my answer is 2. I would get two solutions, which would be absolutely wrong. So you need to think, does it make sense before you solve for absolute value? So that should be step 1.5. Does it make sense? All right, 1 minute left. I need to isolate the absolute value first. Otherwise, it won't work out. I subtract 3 from both sides. Negative 2 equals the negative absolute value of 8 minus y. What's the next step? Very good. Divide by negative 1. We get 2 is equal to absolute value of 8 minus y. Does it make sense? Yes, absolute value can be positive too. So we split into two equations. 2 is equal to 8 minus y. Negative 2 is equal to 8 minus y. I'm going to add y to both sides, subtract 2. Y equals 6. I'm going to add y to both sides, add 2 both sides. Y equals 10 are the two solutions.